Good. Oh, let me give you the microphone. Yes, it's yours. I'll try. I hope that I have pressed something. Yeah. Okay. So, is it okay or okay? So, do you see something? So this presentation is swapped. So if you are confused. So my name is Pavel Krivanek, and I work for Schmidt Engineering Bureau für Bauwesen. We are the small company, consulting company named NIDEA, and in this presentation I will talk about some work, some experiment that we did with Richard Utner about the runtime type collection and its usage for transpiling of the code. So we all like strong dynamic typing, but static typing has also some advantages. Like it's often used for error detection, at least for some kind of errors. It is useful for refactorings because you have more information about the actual types used in the code. It serves for some documentation purposes because you know better what the code does, and it can be used as an information source for a just-in-time compiler. We have the most silly motivation, and it's the transpiling of the dynamic code into the statical language. So for that you need to statically type your dynamically typed code. So the reasons for the static typing are quite good, and some dynamic languages like Close, Common Lisp have a standard way how to represent the types. In realm of Smalltalk, in past there was a Strongtalk implementation which added types to Smalltalk 80 with extension of the current grammar, so it was not clean Smalltalk, and at this time it was the fastest Smalltalk implementation because of the addition of static types, and it's now available as a open source under a BSD license. In Faro there is no standard way how to represent types. There are some ad hoc tries to do that. For example, in block, there were pragmas that described the return values of return types values of methods and so on. And of course, if you have a code, then it's really rigorous to annotate each method with the static type. So people do not like to do that. So our approach to that was automatic. So we try to collect the types during the runtime, and we can infer the rest of the types using royal typer. I must say that that's not what we actually do, but we plan to do it in the future. And then we generate annotations into the code. And of course, if we update the code, then we can repeat this process and keep the types up to date. Here you can see the comparison of our annotations, because we use pragmas for type descriptions. And you can see comparison to Strongtalk that had grammar modification to be able to express the types. Of course, our approach is not that concise and not that nice, but you do not need to change anything in the language. So you define what are the types of the arguments, you specify what the name is and what the type of the object is, or type of the argument is. Then you specify a return type, you can specify each variable, block arguments, and so on. So we use pragmas for this. For block arguments, there is a problem that you can use the same block argument name for different blocks. The best way how to avoid this is to modify your methods to avoid it completely. So use different names, and if it's done completely automatically, we have a prefixes that encode the number of the block in the method. So this way you can use it, but it's not nice for modifications by the program in future. Because of course, if you add some other block, then you need to adjust it. Of course, you need to also type the slots, the instance variables. And for that, we use special method named underscore slot types. And those methods describe or contain the set of pragmas that describe the instance variables. They have the very similar form to the pragmas that are inside methods. If you have simple types, like you have object, variable that can hold only one class, then you just simply may use the symbol name for that. So if it can hold multiple classes, then you can use array of class names. Of course, it applies on subclasses as well. Then the most common, very common case is that you need to allow an undefined object. For this, we have this shortcut that you can write double colon after that. Unfortunately, the question mark is not available because the Faro syntax doesn't allow you to, it's interpreted as two symbols actually, so it's not possible. If you have more complex types like arrays, dictionaries, associations, then we have special hooks for that. So like array of symbols and dictionary of symbols, keys, and so on. And of course, you can embed it. So here you can see the most crazy real-life case we had. So it's a dictionary that as a key has a dictionary, that as a key has an array of strings, and so I will not describe it completely. Then, of course, you have blocks, and blocks need to be also typed. So blocks can have no type information because they have no arguments, no return value. You may describe the return value of the block and arguments, which is the array, and each index of the in the array is corresponding to given arguments. And of course, you can combine that together. Blocks have one more complication because, for example, if you want to convert the block to lambda, you need to know if it's a void or not. So for that reason, we have a special description that says that given block is returning value or not. For example, in select, you always want a block to return a Boolean expression, a Boolean object, but in do, you are not interested in the last expression of the block. And in that case, its type can be actually arbitrary. I mean, a type of the last result of the block. So for that reason, we need to detect if the return value is actually used. So How we collect types? We use metalinks. We install metalinks on various places inside the method. In the beginning, we collect the types of incoming arguments. We apply metalinks on assignments, and of course at the beginning of each block invocation, because then you need to collect the types of block arguments. And of course when we return from the method, we also need to check what the return value is. When the method is metalink is invoked, we activate it. We look at the values, actual objects, and analyze the type and store it somewhere. And of course, this resolving of the type of the object can be quite complex for the complex objects like the dictionaries, with dictionaries, keys, and so on. So it may be slow, but it's reasonably fast. So you do not want to do it all the time, but it's also not something that takes minutes. And after that, we post-process it, like look at the types and try to resolve the common superclass if it's quite close to each other, and so on. And then we write the annotations to the method. And when we write the annotations, we add to the type description one more keyword generated with the true as the argument. And if you as a programmer want to change the type or assign different one, or see that this type information is correct and you do not want to be changed in the future, you can just remove this part or set the generated to false, and then when you will do the next type collecting, it will be automatically skipped. Here I describe how I do the detection of if the block is actually used. As I said, the comparison of select or do blocks. So I take the block literal, I replace it with the custom subclass of block closure that has custom implementation of value or value with a colon and so on methods. And when this block is then evaluated, it returns a proxy object instead of the actual result. And for this proxy object, I detect if some message was sent to that object, or if it was assigned by another metalink. And if it's processed, then I can using become to return to original result. So this way I detect if the result of block was used by the user for something or not. And we use this for transpilation to Faro code to C#. C# has several similar features to Smalltalk. It's a class-based object-oriented language. It has automatic memory management with garbage collection. It has, unlike some C-like syntax languages, keyword arguments, which means that it's easier to convert the message and names, keyword names. Then it has closures that were introduced quite late in 2005. So it was not present in the original version of C#. But on the other hand, it has some notable differences, like it's of course statical typed language with some inference. And it has much more complex grammar. You would say that because Smalltalk has assignments, message sends, and that's mostly all, that it should be quite straightforward to convert from Faro to C#, but it's quite naive assumption. And of course, there are differences in standard library. For message sends, it's very simple. If you have unary or binary ones, then you just need to skip self, and they have uppercase at the beginning of the method names. You, of course, need to adjust the priorities for binary messages, and some binary messages should be converted to actual method sense, like equals. For keyword messages, here you see how it's some method implemented in, or method header in Smalltalk in Faro. And this is how then it's called. So you need to put the parentheses, but you still can use the keyword message. So it's close. To be able to do that, when we convert the method from Faro to C#, we need to actually use the keyword as as an argument name, and that's mostly also because of the code completion. And to be able to do not modify the code of the method so much, we create a variable that assigns the value to the original name. For non-local returns, of course, it's a huge problem for C-like syntax languages. We convert messages like if true, if false, and so on to statements. So C# statements, which means that from them you can actually do returns. So it behaves like non-local returns, and we forbid others. In future, we probably will add a much slower option to actually raise an exception, and then the method itself can behave like as a non-local return. We have some tools to detect such cases that the programmer needs to refactor and to be able to actually translate such method. For statements like expressions, of course, in Faro you can have such things like if true, if false inside another expressions, and it's not allowed in C#. You can do that for expression-like statements like null, colocin, or alternative in C#, but then you need to be sure that you do not embed statements inside those ones. So when we are transpiling, we are actually marking the AST, no AST sub 3, and say if you cannot use statements inside. And when you have code that doesn't pass, of course, then you need to modify it as well. So we are not able to transpile Faro code as it is. We actually need to reduce it to some subset, but in most cases, it's not so horrible to adjust the existing code. One problem is with new statements, because of course when you create in C# some object, you need to define, like dictionary, you need to define type of the keys and values, and in Pharo code you do not have this information. So we try to find the assignment which is related to this new message sent, and detect what is the type of the method of the variable to which you assign. So in the end, we are able to resolve the types of such complex types. And if it's not there, then we mostly just simply create an extra variable that has type annotation, and then we can simply continue. Huge problem is a cascade because C# doesn't have it, and in Pharo in Smalltalk it's used a lot, and it saves you a lot of temporary variables. So we create new temporary variables for each cascade, and of course in Pharo or in Smalltalk the cascade can be embedded. So then and used inside expressions and so on. So you need to evaluate it before, and of course take care on order. So that's more complex than it originally seems to be. Meta classes are of course not present in C#. We use or try to use the static methods for the cases where it's possible. Unfortunately, C# doesn't have polymorphism of static methods, so that's another case where we need to limit what Pharo code can actually provide. And it doesn't have even the polymorphism of constructors. If you are asking yourself why I use such retrofont, that's because of that, because it has all such retro feeling. And for some static methods, if you have a class method that creates instance, we try to detect that and convert it to C# constructors. So for that case, you can we can this way transpile more code than we would be able without that. Casting. Sometimes you need to adjust the types in the generated code. We have message cast as, which does nothing in Pharo, but then it's transpiled to real casting in C#. C# has a huge issue with converting of lists. So if you have a list of some type and you want to pass it as an argument to a method that wants a list of some superclass of that type, it doesn't work like that. It's really nasty. There are ways how to do that using some dynamic cast, and but it's really slow because they actually need to do a copy of the list only because of the type changing. So this way I was able to create a simple benchmark which was for the equivalent code in Pharo like 1 million times faster than in C#. And at some places we found that for us it's quite nice option to detect if we use this message as a return or as a last expression. I mean, it's message used by our application, we save a lot of things, a lot of code if we automatically cast it to method return type, for example. So we wrote the code of the transformer the way that you can extend it with such special cases. And so on. So, for example, for traits, we converted them to interfaces, but of course, then you cannot have stateful traits. For categories, we use regions. We try to preserve the comments of the original code as, of course, even the class comments. C# has extension methods, but they are quite limited. So we do not use them for generated code, but for the standard library imitation of Pharo code, we use extension methods quite often. C# has a really huge amount of keywords, unlike Smalltalk, so you easily get into the conflict with your existing code. So that's something what you need to take care as well. And there is one really nasty feature in C#. You have primitive types, but the primitive types, if are nullable, they are actually represented as structure that says I have value or not, which actually makes impossible to create collection methods that can process every object, because that's something what C# doesn't allow. So we created small experiment, we were able to transpile like 20,000 of lines of code, Pharo code, into C#, which was compilable and working, and it generates the C# code that is readable but not idiomatic, because keywords normal programmers would not use in C#, and so on. But we did it the way that the Pharo code, while transpiling, we were still updating it. So we often regenerated the code. For us, the Pharo code was the main source of truth. As I said, we needed to limit Pharo to only subset, and for that we use small detection tools and refactoring tools to adjust that. And we proved this way that Pharo can be used as a language with optional static typing. We were curious if we will find some type problem, some serious type problem in our existing code, and to our surprise, it's not the case. So I must say that if you want to use statical typing only because of the error detection, it's probably not worth it. And even after that, runtime errors like accessing of nulls and were still common. So you have, even in C#, the same set of issues that you have in Smalltalk, but you need to deal with the types in advance. So to extend our current experiment to extend it more, we want to extend the support of the current Pharo library, involve the royal typer, and improve the way how the non-local returns are processed. We also maybe will try to change meta classes like that. It will create real objects and work with them, and maybe try experiments with other languages like Java, TypeScript, or C#. And this is open source, so you can find it on my GitHub. And thank you for your attention.
Sorry. I've got a question. My C# is a bit rusty, but I remember I abused lambdas a lot and link. Basically, it's I abused it because it's a bit SQL-like, and you can manipulate lists often and cast them and etc. Abuse them in all common ways. So I recommend to.
Of course, we use lambdas, so we convert blocks to lambdas if they are not the ones that are converted to statements.
Okay. And I thought you could use lambdas in statements as with complex stuff, but it's a while.
Of course, we could use lambdas even for that, but that would be not the code that you want to maintain, and it would be much slower, and so yeah.
Hello. Regarding the runtime type collector, or more precisely the type inference part, I know it's a different approach, and maybe that's the answer, but did you consider or did you analyze what Hernan Wilkinson did with the live typing? I don't know if you're aware of what he did, but it might be useful. It's a different approach, as far as I understand. He basically allows, so you run the test or you let your system run for a while, and it will save on every method invocation. It will save somehow the type of a given object or argument, and
I
then
think
it will
it's quite similar approach.
I talked with Hernan at some time. I guess it's the same as we do with the meta links.
Yeah.
Mostly
Okay.
the same.
Okay.
It's straightforward. It's
Okay. Yeah. Hernan is in the VM. Now you are here. You do it with metalinks.
we are doing with metalinks. For this, of course, you need ideally 100% test coverage. And,
Exactly. Yeah. Or have your
Which
system
should
running.
be normal. So
yeah. Exactly. You need tests.
or at least be able to run most of the applications.
And then my second question, but this is more long term. If you consider, since you already paid the investment or the time to type or to make your code write the type, did you consider making like live typing does? It's have kind of your own tools. Like for example, you look for senders. You now have much more precise information.
Yes.
Than the average.
For that reason, it would be nice if there would be at least some standard that everyone could follow.
Exactly. Exactly. Yeah, I agree. Okay.
Yeah, I think it was your second slide where you had the pragmas. I once wanted to add block local pragmas, so you could add pragmas to blocks as well, not just methods. Did you investigate if that would be a lot of work? Because I never got off the ground.
Of course, we didn't want it. It was just a quick experiment. We didn't want it to modify the existing grammar. So for that reason, we had to do the prefixes for. So it would be nice, but it's not possible in Faro currently. So we may discuss if it's worth to modify the compiler.
It's a nice extension.
I agree. Yeah.
Thank you. I was wondering why, because you're saying code transpiling, but that can't be the
because
goal in itself. So I was wondering.
Because we had code in Faro, but the management decided that and it's quite reasonable decision. The application is working with things like Microsoft Office, and we use anyway a lot of C#, and we wanted to have this code in the C# for the C# programmers. So that's why it's because of the Windows and better coordination with the C# world.
Hello, I would like to ask two questions. First, could you use any experience from Farad.js or Squeak.js in translating small talk in a different language?
We wanted to create readable C# code. And if you look what C# what Squeak.js generates, it's a horrible mess. So you do not want to maintain it.
Okay. And the second question is, you have database-oriented as an information system, which type data in a database. Could you use this data as a starting point for the type inference?
I didn't understand.
You have an information system, and this information system has a database. And in this database, there's existing typed data. Could you use this data as a starting point for your type inference?
Probably.
We had a globe-based system, so we had all the type information because we mapped everything to globe. So we used that directly to infer what we want to map in C#. So that was the easy part for us.
So it's time for lunch, I think. So.
Thank you.